Welcome to the Executive Spotlight Q&A, a sponsored Light Reading audio production. This is Phil Harvey. I'm an editor here at Light Reading, and today's Executive Spotlight features someone I know very well in this industry, Metaswitch's CTO, Martin Taylor. As you'll soon hear, Martin Taylor is uniquely talented at explaining how the technology of the cloud giants, the hyperscalers like Google and Amazon, has and should continue to influence the direction of telecommunications infrastructure. Metaswitch Networks as a company really embraces the philosophy of building out cloud-native software, and they really do relish a technical challenge. Their latest achievement in this area is a test they've done with Vodafone around something called 5G wireless wireline convergence. So what does cloud native mean now, and why is that definition changing? And also, how is cloud native going to shape broadband and wireless infrastructure going forward? You will find out all of that and much, much more in this Executive Spotlight featuring Metaswitch's Martin Taylor. First of all, we're recording our Executive Spotlight Q&A with Martin Taylor, CTO of Metaswitch. Martin, thanks so much for joining us.
Pleasure.
Glad to be talking to you today because we have to talk about the 5G core and how the 5G network is evolving. And Metaswitch is once again in a piece of it that seems really interesting and really kind of timely to those of us watching from afar. So it's been a while now that Metaswitch has been talking about cloud native software and really advocating for cloud native software in the industry. Let's talk about why cloud native software is so important in the communications industry, and then what the relevance is in when it comes to building 5G networks.
So building software to cloud-native architectural principles is essential for the kind of operations automation aspects of network function virtualization to be properly realized. The industry has learnt to its cost that just virtualizing appliances according to the vision that was originally put out there by Etsy and the telcos who wrote the white paper, actually doesn't. It changes things in that stuff's running on commodity hardware, but it doesn't change anything else, and it doesn't enable you to leverage all of the benefits of doing stuff in software with APIs, with all of the potentiality of highly automated operations. So the cloud native, a lot of people say to me, well, everybody says they're cloud native, so how are you different? And I think the challenge here is that everyone has recognized that cloud native is the right way to do stuff. And so naturally enough, everybody claims their stuff is cloud native. The way we think about cloud native, it's really a collection of architectural best practices as seen in the web scale world. And it is something of a moving target because, of course, the web scalers, keep on evolving the way they do stuff. So what you would have described as cloud native 4 or 5 years ago when we introduced our cloud native IMS core looks significantly different today, because in those days, everything was deployed in virtual machines. Now, the web scale best practices, you deploy in containers, you orchestrate with Kubernetes, you instrument with a whole bunch of open source projects like Prometheus and FluentD and so on. So that's what cloud native looks like today. And what we've done with our solution for 5G core is, essentially to snapshot all of those best practices today, and starting with a completely clean sheet of paper, build the software to that architectural approach. And that does mean that the software is extremely automatable across the whole range of things that people need to do to manage something complicated like a packet core.
Yeah, I think the clean sheet of paper approach is the thing to really highlight here, because that seems to be where NFV got derailed the first time around was people just trying to simply replicate network functions that were built on purpose-built devices in the cloud, and it didn't allow for as much automation and some of the more advanced flexibility and functions as a truly cloud native approach can.
That's right.
Let's get into what Metaswitch is doing here. Metaswitch has talked about its 5G wireless wireline convergence test with Vodafone. I'll just ask straight out, what is 5G wireless wireline convergence?
So this is an initiative that's been evolving over the last 18 months or so between the standards bodies responsible for wireline broadband access and 3GPP, which is responsible for the mobile and 5G standards. Mm-hmm. It's been driven by a bunch of operators who offer both mobile and wireline broadband services. Who've observed that they are running those services out of completely independent and separate technology stacks. So, in effect, wireline broadband, mobile broadband are technology silos with no commonality in any sense. And the observation has been, well, 5G packet core is a powerful, highly manageable broadband services edge. Why can't we use that to deliver not just mobile broadband, but also wireline broadband, and have a single technology stack in the back end that reduces the number of different technologies that we have to deploy. And of course, remember that network operators are busy virtualizing their networks and working outwards from the core towards the edge. So up till now, the wireline broadband services edge hasn't really been virtualized. It's still running out of physical broadband network gateways. So as they look to virtualize that piece, they're saying to themselves, well, we've got to virtualize the 5G core, and that's all brand new cloud native technology. Why don't we just leverage that to bring in our wireline broadband traffic, simplify the technology stack, and unify our subscriber management policy, charging, and all that stuff across our entire population of subscribers. So wireline, wireless, they're all getting looked after from the same back end, same BSS, OSS, and so on.
Okay. It certainly makes sense if you're virtualizing all parts of the network and you're delivering broadband on two different paths. Why not unify those paths somewhere up the stack, I guess?
Absolutely.
Okay, so Metaswitch is one of the components in the 5G wireless wireline convergence is Metaswitch's access gateway function. What is the role of the AGF in this sort of scenario?
Well, so this is the key new network element that's been defined by Broadband Forum working with 3GPP. Think of it as the glue that sits between an existing wireline broadband access network and the 5G core. So it sits behind the wireline broadband access nodes, and that is GPON optical line termination units. It is DSLAMs in the DSL world. Mm-hmm. And it looks to them like a completely standard broadband network gateway. So it presents the standard service edge interface specification, which is the V interface that Broadband Forum defined. And then on the upstream side, it presents the N3 interface to the 5G core. So it looks like a 5G radio base station, a G node B. So it's a kind of interworking function, if you like. But as I say, it allows you to take your entire install base of wireline access nodes and the residential gateways that they service, and hook that up to a 5G core, which then performs essentially the same role as a broadband network gateway does. It authenticates and authorizes attachment to the service. It then applies, it obviously provides a path between those users and the internet, and it applies a policy to that subscriber service, throttles the bandwidth according to what service tier they have, maybe applies some QoS so that you've got sort of some differentiated service capabilities in there and so on. That's what the AGF does.
Excellent. Okay. And this is to get into the specifics of it. The AGF, is that a piece of hardware, a piece of software, or a combination of both?
Well, of course, the standards don't define how you implement this thing, but of
Right.
course, these days you want to implement this thing purely as software. That's what we've done with the Fusion Core AGF. It is another piece of cloud native software. Think of it as an extension to our cloud native 5G core. It's architected just like our UPF, our user plane function. It in that it's packaged in containers, deployable with Kubernetes as the orchestrator, highly automated, elastic scale out, N plus K redundancy, the ability to upgrade the software and service. All of that those good cloud native things are embodied in the way that we built our AGF.
Okay, excellent. So you deployed this in Vodafone's labs, and I'm told that the whole deployment was done remotely. As this is cloud native software, that's of course possible to do. It's also quite convenient because we're recording this in the time of most of us are observing stay-at-home orders for during the COVID-19 pandemic. But what would have been different, I guess, if we had not been in the midst of this pandemic? Would you still be able to deploy this remotely in a carrier's lab and do all the things you would normally do to stand this up and get it up and running?
Yeah, I mean, it is usually possible to deploy a piece of software remotely. I think the big difference in this case is the degree of automation that we applied to enabling that deployment. And I think this is one of the areas in which I think we quite impressed the Vodafone technical team here, because we used an open source technology called Helm, which is a way of automating the deployment of Kubernetes applications. And essentially, it's you define a template that says this is how we want the application to be deployed, and then it's one click, and all of the standing up of the different components and containers and Kubernetes pods and so on is completely automated. So that kind of one-click deployment, certainly made an impression in this case. And of course, when you're thinking about, well, how does an operator actually roll this out? I mean, the AGF is out at the edge of the network, and probably there are going to be in a nationwide network hundreds of instances of this stuff. So being able to stand it up, with a one-click automated deployment operation is kind of fundamental to the business case, if you like, for deploying this stuff.
Yeah, that makes sense. So let's talk a little bit about the Metaswitch 5G Fusion Core, because you had made reference to it earlier about how the AGF is part of the Fusion Core, along with the UPF and other components. What got Metaswitch into the 5G core business, and why does it feel like it can be a really competitive player in that space?
Well, the simple answer is that we did it because we can, and because we like to take on interesting and difficult problems. But that certainly doesn't answer the question of how do we think that we can be successful. Certainly, I mean, we are absolutely a new entrant into the mobile packet core space. I think we alluded a little bit to the clean sheet of paper approach that we took here. And actually, I think the fact that we have never been in the mobile packet core before meant that we had no legacy code base, which to take forward into the 5G world. Now, that's a blessing and a curse. It's a curse because we have to write a lot of stuff from scratch, but it's a blessing because we're not saddled with any legacy architectural baggage that prevents us from being truly and properly cloud native here. So starting with a clean sheet of paper, we were able to build stuff, absolutely according to those latest cloud native principles. And, that's where this very high degree of automatability comes from. Now, when it comes to, well, okay, but you're up against a lot of, incumbent competitors, I would say for sure, what we're providing is, it's not obvious that an existing a mobile operator with an existing massive large scale deployment of LTE packet core, the evolved packet core, is going to see our 5G core as a sort of natural evolution path. But the thing to realize about 5G is that there are a lot of brand new use cases that 5G enables,
Right.
and that's where the Fusion core really shines, because it is properly cloud native. We have demonstrated phenomenal performance from our user plane in pure software, and that's very useful in the context of wireless wireline convergence, particularly because the thing to remember about wireline broadband customers is they consume at least an order of magnitude more volume of traffic than mobile broadband subscribers, but typically at a lower average revenue per user. So
Mm-hmm.
the economics of your user plane in wireless wireline convergence are much more challenging than they are for mobile broadband, and therefore you need super high performance, super efficient software to implement the user plane, and that's an area that we have excelled in. The other area that we've excelled in is in the extreme breadth of scalability that our approach brings, and that again is a byproduct of taking a properly cloud native approach. With cloud native, what you do is you implement each microservice so that each microservice is based on running a large number of very small software instances,
Mm-hmm.
and you scale out just by having more and more of them. But what that means is that you can also scale very small. And we've been able to show Fusion Core running on a 4-core, handheld device. We also demonstrated it at one of Microsoft developer conferences, running on their Azure Stack Edge box, and we're unique in that capability. Everybody else that's kind of taken a legacy software evolution approach, it needs a lot of big iron in order to run their packet core,
Mm-hmm.
and just simply cannot run on a small box at the edge. Now, you may say, well, what's the use case for that? Well, the answer is it's private cellular, and
Yeah.
with CBRS now having come on the stream, lots and lots of interest from industrial, logistics, transportation, those kinds of users who want wide scale, much wider scale wireless support than Wi-Fi can offer. But they need a local private packet core because they want to run low latency applications. So they need the small footprint for that.
No, good reminder too that being scalable in the technology world doesn't always refer to getting bigger.
Indeed,
It's
small is good sometimes too.
yeah, exactly. Perfect. So let's talk about one more component of the AGF and the access gateway function in this wireless wireline convergence, and then maybe we'll talk a little bit about what your customers are saying about 5G core. So first off, part of this. Part of what's powering the AGF function is what Metaswitch is calling the Composable Network Applications Processor, or CNAP. Can you tell me a little bit about what that is and what it does?
Yeah. So when we started on our 5G core journey, we realized that the hardest technical problem that needed to be solved was the packet processing performance of the user plane function. For a long time in this industry, there's been this debate about whether pure software solutions could ever compete successfully against proprietary hardware in the packet processing space. And the user plane function and the AGF are nothing if not packet processing functions. I mean, they're doing quite a lot of work on packet flows between users and the networks that they're accessing, in terms of tunnel encap and decap, the application of policy, firewalling, carrier grade NAT, those kinds of things. That's heavy lifting in the packet processing space. And traditionally, people have used proprietary hardware to do that. Well, as a software company and wanting to do things properly cloud native, we decided we needed to do this entirely in software without any kind of hardware acceleration. We can leverage hardware acceleration, but we don't need it. And what that meant was really going to extreme measures, if you like, to maximize the efficiency and flexibility of packet processing software. So again, I mean, here one of the things you do in cloud native software development is you go out and scour the open source world to see if there are solutions out there that could fit your need. But in the case of high performance packet processing, yes, there are certainly some solutions out there, but we felt that they were all, first of all, flawed in their conception and execution, but also, we felt we could do much better in overall performance terms. So again, we started with a clean sheet of paper. We built this piece of software we call CNAP. It's a configuration-driven packet processor. So it's a general purpose piece of software where we can construct a template or a configuration that describes the packet pipeline we want. It describes the sequence of operations we want to perform on a packet as it flows through this thing, and therefore modify it very quickly. And it has phenomenal performance. And we achieve this by making very creative use of the Intel architecture instruction set. There's been a lot of interesting new instructions that have been added over the last few years, which, if used creatively in packet processing, can make a major, major difference. There's just a lot of secret sauce about how we use the data and instruction caches and so on. Now, the proof of the pudding here is that we had our UPF tested in conjunction with Intel. They provided a test regime, traffic profile, a set of functionalities that we needed to show in the pipeline to emulate, a real world 5G user plane function. And we demonstrated 500 gigabits throughput on a single standard off-the-shelf 2-socket Intel server without any kind of hardware assist at all. And they were blown away. I mean, they said to us, how in heck did you guys achieve that kind of performance? Because it's 2 to 3 times what we had believed was the theoretical limit for this architecture. So that's the kind of technical underpinnings, if you like, across now any new packet processing thing that we do will leverage CNAP. User plane function for the 5G Fusion core is certainly the first application, but we've used it also for AGF for obvious reasons.
And if I translate that into what that means, to a service provider, it essentially means that you'll be able to eventually do harder and harder, functions on older hardware. Not necessarily having to have the very latest hardware to run some of these more complex functions.
So I mean, if you're putting new hardware in place, whatever processor or whatever server type you select, we use less of it than anybody else's software on the planet. That translates directly into reduced total cost of ownership.
Yeah, which is definitely a box that carriers are wanting to tick. So the last question, we're talking about the 5G wireless wireline convergence and the test that's going on, the trial that's happening in Vodafone's labs. So obviously you're talking to carriers about what they need in the 5G core, what works best in 5G core deployments. What are you hearing from your customers in terms of best practices for the 5G core?
So we're hearing pretty universally that that operators are expecting their vendors to deliver a properly cloud native application. But I think, but we're also perceiving a lot of differing views about what truly constitutes cloud native. Because, in our view and the view of the web scalers out there, cloud native absolutely means containers and Kubernetes and, that whole ecosystem, that trail map. If you refer to the Cloud Native Computing Forum, the CNCF, there's a whole bunch of materials there that talk about what Cloud Native is, and that's the kind of canonical reference material we should be using to, as a set of criteria to judge whether an application is truly cloud native or not. I think what we're seeing is network operators, they may be aware of that, but they seem to be presented with a lot of offerings from their vendors that I wouldn't say measure up in any shape or form to those criteria. So that's a little frustrating to us because we think we stand head and shoulders above the pack in terms of properly implemented cloud native principles, but it feels like those principles are being watered down quite a lot as network operators get their heads around what they can realistically obtain from their incumbent vendors.
Well, hopefully these these lab trials and the sort of the work you're doing with Vodafone will help get the word out, and maybe they'll start scratching their heads a bit and changing their minds.
Yes, I mean I think seeing real world cloud native with Kubernetes and containers, particularly for something operating in the user plane, I think this is one of the areas where we are very different. I think it's much easier to build cloud native solutions in the control plane space, but user plane is a much more challenging problem, as I mentioned earlier. So we're hoping that this will open their eyes to this is the state of the art now, and start holding their other vendors to account, if you like, in that light.
Excellent. Okay, Martin Taylor, thank you so much for joining us on the Executive Spotlight Q&A.
It's been great talking to you, Phil.
That is it. That's our show. Thanks very much to Metaswitch CTO Martin Taylor for his time and insights today. Thanks to our producer, Tian Fu, for his fine work on this production, making it sound so good. As noted before, this is a sponsored audio production of Light Reading, and the Executive Spotlight does not necessarily reflect the views of Light Reading's editorial staff, though sometimes it actually does. To schedule your own Executive Spotlight Q&A, please contact the Light Reading sales department. The email address you should have is sales@lightreading.com. Thanks for listening.